right? So, and let's say this is U. So it has two components, right? Horizontal component and vertical component. So due to that, we have this range and we have this height. So these things we studied in the last class. And what happens? What happens when we project this thing, right? From the top of the tower. Let's say we project with horizontal, right, projection. So this is horizontal projection, and this is angular projection. So in horizontal projection, what do we have? We have this is only U, right? So we have how many components of this velocity do we have? How many components? Yes, how many components do we have? So we are talking about motion in two dimensions, right? Motion in two dimensions. So everything has two components. Velocity has two components, Vxi, Vyj. Distance has two components, right? Let me write it as r. This has two components, xi and yj. Acceleration has two components, axi, ayj, and yeah. So the all these things, these parameters have two dimensions. So they have two components. But for the acceleration part, we know that in x direction you don't have any acceleration. Only you have ay, which is g, right? Okay, who got disconnected? So we have only ay and equals to z, and this has a sign convention, right? So because we are only talking about the horizontal projection, then we only have what component of velocity do we have? What component of velocity do we have? RJ, can you tell me? Yes. So what component of velocity do we have? In earlier, you saw that this was projected with some angle. So it had horizontal component, which was u cos theta. This was u sine theta, right? That thing we talked about in the last class. So what we will have when we are projecting this horizontally? So it will only have horizontal part, x, right? Vertical part is 0, right? Is it clear? Is it clear?
Yes, sir.
Yeah. So we have this initial velocity, and then all those four equations, or mainly three equations, right? So we have three equations. One is v equals to u plus at. So we will have x component only, right? And then we have x equals to uxt plus half axt square, and then we have vx square minus ux square equals to 2axs, right? So this is x component part, and then we have y component. The y component part is what? Vy equals to uy plus ayt, and we have y, which is uyt plus half ayt square, and vy square minus uy square, that is 2ay, and this is not s, but this is x, and this is y. So these are the component wise distribution, right? And for the horizontal part, this part is only there, only x part is there, this is 0. So this will cancel out, right? This is 0, this is 0. All these things are 0. And we also know that ax is 0, right? So this part is 0, this part is 0, this part is 0. So for horizontal case, right, for x component, the final velocity in the x direction is equal to the initial velocity in x direction. So in x direction, you have to remember this, that in x direction, velocity is constant, right? So initial velocity is equal to final velocity in x direction. So this direction velocity will always be same, right? This will always be same. This will change. The vertical part will change because this is dependent upon ay. Now we are going downwards. So ay would be plus g or minus g. What would be ay? Can you tell? Yes. What would be ay plus g or minus g when we are going downwards? Yes. Uh, yes. Hello, hello, Alia. You got disconnected, right?
Yes, sir. Sorry.
Yeah, no, don't worry about that. Those are technical features, right? Okay, so let us continue, right? What we were discussing that we are throwing this object without any angle. So this is horizontal projection, right? In horizontal projection, what are the final velocity, what is time of flight, what is range? So all these things we want to find out, right? So let's find that out. So we know that this would be always same, right? Final velocity will always be same as the initial velocity in horizontal direction. But if we talk about the final velocity in y component, so this would be ay, which is g, and t. So this would be the final velocity. And if we write the distance, so let's say that y distance, this height is given. This is some h, right? So y is h, and this would be equal to half, and ay is g, and t square. So this would be how much? So t would be, this is 2h by g and root over. So this would be the time of flight. This is time of flight for the case of horizontal projection, right? And let's say that this distance is r, right? So this r is related with this x. So r is u x t. U is u and this is t. So we can write this r as u and 2h by g. So these are the relation in the horizontal projection. Okay, is it clear?
Yes, sir.
Yeah, so we'll use these things and then we'll try to find out the rest of the things. So let's solve any other questions, right? And yeah, and then we'll talk about relative motion. So first, let us talk about. So we have this question, right? We have this question, and what are the things which are given? Yes, yes. So you got disconnected again. Yeah,
Yes, sir.
yeah.
Sorry.
No, no, don't worry about that, right? So, don't worry about that. So what we need to remember, now we will do some questions. And what we need to remember is that whenever we are horizontally projecting something, then the time of flight is root 2h by g. Range is u 2h by g. So these are the two things that we have to remember. And earlier we saw that with angular projection, this is the time of flight, height, and range. And this is the equation of trajectory, right? So have you noted all these things down? Have you all noted all these things down?
No, sir. 1 minute.
Okay, yeah. So this part you have noted earlier, right? Okay, but okay, yeah, you just note it down quickly. Just note down the formula, right? You don't need to write down everything. So just note down this thing. This is the equation of trajectory, right? Just note down this thing. This is very, very important. So you can do many question using this one. And then this formula is important. Whenever you have noted down these two, please tell. Yes, whenever you have noted down these parts, please tell.
Done, sir.
And then only note down these two things, right? So this is for the understanding purposes. If you know this thing, then you can derive all these things. But in the exam, entrance exam or that exam, right? So you have to just remember these two. So just note down these two things. Okay. So this is for horizontal projection. Whenever you have noted, please tell. Yeah. Whenever you have noted, please
Done, sir.
tell. Yeah. Okay. So using these ideas, let's do some questions. This is the first question. A relief food package is dropped from an aeroplane which is moving horizontally with a speed of with a velocity of 30 meters per second. So we know that what kind of projection is this? What kind of projection is this? So helicopter is right. So let's say we have this helicopter. Right. This is moving. So what kind of projection? And let's say this is the ground. This is the ground. Right. Now this is moving with 30 meter per second, and then this is at a height of 50 meters, and it drops a food packet. So this will move like this. Right. So this is a horizontal projection, and u is given 30 meter per second. Right. So time of flight we need to find out. We already know that time of flight is 2h by g. Right. So this would be simply 2 height is 50, this is G is 10. So this goes over and root 10, which would be 3 point something, right? So this is, or we can just stop at root 10, right? And then we need to find out location of point of striking the food equals to R, right? So we have to find out from the ground, right? From the ground, we need to find out that what is this R, right? So R is how much? This is U 2H by G. So U is 50, U is 30. So 30 root 10. And then we have to find out velocity of package at the time of striking the ground. So what is the velocity, final velocity, right? We know that final velocity will have two components. So this is Vxi plus Vyj. And we already know that this doesn't change. So Vx is Ux, that is 30 meter per second. But Vy we need to find out. So Vy is how much? Vy is Uy plus Ayt. Uy is 0, Ay is G, and T we have already calculated. So this is root 10. Right, so how much is this thing? So 10 root 10, right? So we have Vy, we have Vx, then we can calculate magnitude of V. That would be Vx square plus Vy square. And this is Vx square is 30 square, right? And then Vy square is 10 root 10 square. So this is 900 plus this is 100 and into 10, right? So 100 into 10. So that is 1000. So this is root 1900, which is 10 root 90. So this is the final velocity with which this object which is thrown, this strikes the ground, right? And the last part that we need to calculate is displacement of food package. So food package was here, and then now it has reached here. So displacement is this thing, right? So this is the displacement. And how can we calculate this thing? So we know that this is 50, this is R. So this would be hypotenuse. So displacement is simply root of 50 square and then R square. So this is 2500. R is how much? R we have just calculated, that is 30 root 10. So 30 square. Oh, you are here. I thought that you got, again you got disconnected. So this is 2500 plus 900 and then into 10, so that is 9000. So how much is this thing? So this is 11500. So this is 10 root 115. So these are the values that we'll get. Is it clear to you? Is it clear?
Yes, sir.
Yeah, so these are the questions that will be asked, right? And these are some direct questions. So if you understand this problem, then you can do the next set of problems, too, right? So please quickly note this one down, and then we'll do the next question. Please note down this thing. And whenever you want me to scroll down the screen, please tell me. Yeah, whenever you have a noted, please tell.
Sir, can you scroll down?
Yeah, whenever you have completed noting it down, please tell.
Done, sir.
Okay, good. So now we have a similar kind of question, right? This is a similar kind of question, so let's do this one. So we have a helicopter is flying horizontally. Again, this is horizontal projection. So helicopter is flying right, and okay, so and then this is flying in this direction, and then it is at a height of h. Altitude is h. Some man is standing in air, right? And the food packet is dropped. So the food packet is dropped, and we need to find out that what is the distance of helicopter from the man. So this distance we have to find again, right? My drawing is pretty bad, so let me draw it properly. So this looks like this, and then this is the distance that we need to find out, right? So again, we have to find out r, and then we have to find out this distance d, which is the Pythagoras theorem. So what is r? Can you tell me what is r? What is r? So this was u root 2h by g, right? So this would be how much? So what is that? So what is this thing? H is small h, and u is v, right? So this thing we already know. H is also given. So what would be d? What would be d? So d is simply h square plus r square. So this is h square plus r square would be how much? That would be v square and 2h by g, right? So what is the correct option? What is the correct option? This one, right? 2b square h by g plus h square. So this is the correct option. Is it clear? Yeah, is it
Yes, sir.
yeah, so this was a direct problem, right? So just note down this thing, and then we'll do for the other question. So quickly note down this. Yes, whenever you have noted, please tell.
Done, sir.
Good. So now let us try the next question, right? What is the next question? And this has been asked in NEET, right? So the velocity at the initial point, this is thrown with some, right? So at initial point is this, and it is thrown with some angle, right? So this has two components. This initial velocity, this is u, which is given as 2I plus 3j. So ux is 2, uy is 3, right? Correct? Yes, is it correct?
Yes, sir.
Okay, so now you see that this part, right? This part is the x velocity. So this remains same in projectile motion. This remains same. So Vx, final horizontal velocity, this would be also 2, right? And you can see that y is 3, y is 3. So if you check the options, right? If you check the options, so you see that in here, what is the velocity which remains the same? So in here, the final velocity would be Vxi plus Vyj. And you see that this would be Vx is 2. So this would be 2I plus Vyj. So if you see the options, this option has 2I, this option has 2I. But you see that in this option, this is saying that this is in upward direction. Plus 3j means that this is going upwards. But at B point, this is going downwards. So which would be the correct option? C or D? Which would be the correct option? Can you tell me? Yes, which would be the correct option?
C.
C, right? So this would be minus. So this was the idea. Only we have to remember that the horizontal speed remains same, right? In the projectile motion, horizontal speed remains the same. That is the idea that we have to apply. Quickly note this thing down, and then we will talk about the next question. So I will do one question more, and then we will talk about relative motion. Just note this thing down. Yeah, whenever you have noted, please.
Done, sir.
Yeah. Okay, so then we will do this question, right? So let's do this question and yeah, skip this. So this is same as this. So we will do this question, right? And to do this question, we need to remember this trajectory. So I have already written this thing because this thing we have discussed. So this is the equation of trajectory, right? And using this thing, we can do this question. So you see that You see that they have written the trajectory of the projectile in this form, right? So y is alpha x minus beta x square. And if you compare these two, let's say equation 1 and equation 2. If you compare these two, so what would be alpha? Can you tell me? What is alpha? Just see the coefficient. This is x tan theta. This is x alpha. So if you compare these terms, first term, if you compare the x term, you have x term, you have x square term. So if you compare x term, then x term in here has tan theta, x term in here has alpha. So if you compare, so alpha would be tan theta. Clear? Here.
Yes, sir.
So theta would be tan inverse alpha. And let's check the options. So this option has tan inverse alpha, and we have two options, right? So this one and this one, which means that we have to also find out the maximum height h. So h we need to find out, right? Okay, so to find out the h, what we need to find out? So we know that h is u square and sine square theta by 2g. This is q square, or this is the height. And if we compare x square from here, right? If we compare x square from here, so what we will get? We will get beta, that would be g by 2u square cos square theta, right? So this is beta. And you see that we have h is equals to u square sine square theta by 2g. So we need to find out h, and we need to write this thing in terms of sine square theta, right? So how can we solve this thing? So we can calculate u square from here, right? Because this is the value that we need. So if we calculate u square is how much? U square is g by beta and 2 cos square theta. This is u square. And if we put this value in here, so what we will get? We will get g, and this is how much? G by 2 beta cos square theta sine square theta divided by 2g. So g and g cancels, right? Sine square theta by cos square theta is tan square theta and divided by 4 beta, right? We already know that what is tan theta. Tan theta is alpha. So tan square theta would be alpha square, and this is 4 beta. So now we have the answer. So alpha square by 4 beta. So this is the correct option. So this is the option. Right? Is it clear to you? We just need to remember this equation of trajectory. So if we remember this, then the answer will be clear. Yeah, if it is clear, then please note it down. And if you have any doubt, please tell. Otherwise, just note it down and please tell me whenever you have. Yeah, whenever you have noted, please tell.
Done, sir.
Done. Okay, before I go to the next part, can you tell me what is the case for which there are two ranges which are same? So in a projectile motion, right? In a projectile motion, this you have learned, you must have learned in your CBSE class. So what is the case at which, right, those two projectile covers the same distance? What is the case? Yeah, so we have this thing. This would have R1, and let's say this thing. This is R2. So what is the relation between this theta and this thing, right? So that both covers same range. Do you know the relation? For which ranges are same? So they will cover the same distance. If you throw it with theta and if you throw it with 90 minus theta. So this is a point to remember. Let's say if you throw it with 30-degree projection and if you throw it with 60-degree projection. So both will have same range, right? So this is a point to remember that R1 equals to R2 if the angles are complementary, right? Which means that one angle is theta, the other is 90 minus. So this is the important point to remember. Okay, yeah. So now let us move on to the next thing, which is relative motion. So you need to remember that what are the equation based on this relative motion. So in relative motion, in two dimension, and this thing is used, right? This thing has an enormous use in Rain-Man problem, right? So we use, let's say VA is some velocity, VB is velocity. So relative velocity of A with respect to B, this we have learned in one dimension. This is VA minus VB. So this is relative motion in 2D. And if you want to do this Riemann problem, so let's take an example, right? So rain is falling down, right? This is the velocity of rain, and the man is going, let's say, towards east, right? So this is west, right? So this is east, and this is west, and this is north and south. So the man is going towards east, right? And let's say this is the velocity of. So if I want to calculate velocity of rain with respect to man, so I need to write VR minus VM, right? And for that, I have to just take this VM in the opposite direction. So this is minus VM, and then I have to take the resultant of this. So this would be the velocity of rain with respect to man, right? And this question becomes very simple if we use IJK formula, right? So velocity of man, if I use IJK formalism, this would be velocity of man magnitude and I hat direction. And velocity of rain is velocity of rain magnitude and minus j hat direction. So this is minus VR j hat. And if I want to calculate velocity of rain with respect to man, So this would be VR minus VM. So this is minus VRJ hat and minus VMI hat. So this would be simply minus VMI hat minus VRJ. So this is how we do in the IJK form, right? And what would be the angle with the horizontal? So with the horizontal, this angle would be, with the horizontal, this would be VR by VM. But if I am taking with vertical, so with vertical, right? So this would be simply VM by VR, right? What do I mean by vertical and horizontal? So if I'm taking this angle, this is vertical. This is with the vertical, right? And this would be tan theta, which would be VM by VR. So this thing we have to do, right? Okay, so is it clear? Is it clear?
Yes, sir.
Yeah, so these are the things that we have to remember in trainment problem, and this is related with relative motion, right? So just quickly note down this thing, right? IJK formalism is easy. With IJK formalism, we can understand it properly, but yeah, so this one is difficult to understand. Okay, so whenever you have Riemann problem, you have to just use this relative motion. Just note down this part. Just note down this part, and then I will talk about river crossing, and then we will do some questions. Yeah, note it. And if you have any doubt,
Done.
please tell me, because in Riemann problem, right? So in Riemann problem and in the river crossing problem, there are numerous doubts. So if you have any doubt, please tell. You have to just remember that in a Riemann problem, we have to use the idea of relative velocity. And then you have the river crossing problem. So in river crossing problem, you have to use the idea of resultant of vectors. Right. So what is the river crossing problem? So we have this river, and let's say this is the velocity of man, and then this is the velocity of the river. So river is flowing in this direction, right? So this is the velocity of the river. So resultant of this man with respect to the river, this would be the resultant velocity of man with respect to r. And this is what? This is resultant, not relative, right? So we can use the Pythagoras theorem to calculate the resultant velocity of man with respect to river, and this would be Vm square plus Vr square, right? And I can write also the IJK formalism. So in IJK formalism, what would be this thing? Vr is simply V r I hat. Velocity of man is Vm j hat. So Vmr, this is Vm plus Vr because we are calculating the resultant. So this would be Vr I hat plus Vm j hat. And from here you can also see that what would be the magnitude. Magnitude is simply Vm square plus Vr square. So we'll get the same result using the idea of ijk. So this is the case when you are going in upward direction, right? So this is the case of upward direction. But this is also called shortest time approach. But you want to cover the shortest distance, right? This is the distance that you are covering. So you want to cover the shortest distance. So for shortest distance, and yeah, before I do call the shortest distance, this is called the drift. So this is called the drift distance, right? So this much the man has drifted due to the flow of the river. And this drift distance is only dependent upon the river. So the drift distance is simply VR into T. Right. Okay. So now let us talk about the shortest distance. So for shortest distance, right, this is the shortest distance. And if the man wants to cover this shortest distance, then he has to move in this direction. So this has now become the velocity of man. This is the resultant, right? And this is the river velocity. And if we use the Pythagoras theorem in here, so Vm square, this is Vmr square plus Vr square. So Vmr, this would be equal to Vm square minus Vr square. So this is for the shortest distance, right? And this is the angle theta with the vertical. So this angle would be how much? Tan theta is Vr divided by Vm, right? So this would be Vmr, right? So perpendicular by base. Okay, so this would be Vr divided by Vm square minus Vr square. So this is tan theta for the shortest distance. Okay, are these points clear? Are these
Yes,
points?
sir.
And you have to also, so this is also the case for the wind problem. So wind problem you will also use. For the wind problem also you have to use the resultant of it. So we use the idea of relative velocity in 2D in Rainman problem, right? And yeah, just note down this thing and then we'll do a couple of questions to understand this. So just don't note down. If you have any doubt, please tell me. Yeah, whenever you want me to scroll down the stage, please.
Sir, can you scroll down? Yeah, tell me whenever you have. Done, sir.
Okay, so now let us do some questions, right? And yeah, let's do this uniform circular motion as well. And then this will complete your chapters. In uniform circular motion, we all only need to remember that, right, whenever the object, so in a uniform circular, so in uniform circular motion, we have this thing, and this is moving with constant velocity. So magnitude is constant, but direction is always changing. Right? Direction is always changing, and due to change in direction, we have this acceleration. So the acceleration is always towards the center. This is the acceleration, and this is called the centripetal acceleration, and this is denoted as omega square r. And then you have the relation between the linear velocity and the angular velocity as omega r, where this omega is angular velocity, right? And because you have uniform acceleration, right? So this angular displacement, let's say theta, this is called the angular displacement. And from this theta, you can define this angular velocity, which is d theta by dt. If you have a parametric form of theta, if theta is a function of time, right? So this is called the instantaneous angular velocity. This is instantaneous angular velocity. And if you have a constant theta, so this omega is simply theta by t, right? And then you have this average angular velocity, and this is simply delta theta by delta t. This is average angular velocity. So all these things you have to remember in the uniform circular motion, right? And yeah, so these are the things that you have to remember. Okay, so just quickly note down this part and then we'll do some questions. Yes, noted.
Done, sir.
Then, okay. So in vector form, you have to just remember in vector form, this would be omega cross. Yeah, this is not that important. So this completes this second chapter or the third chapter, right? And now let us do some questions. So this question we have done. So now let us do all these questions, right? Yeah. There are questions to understand concepts. Okay, so let's do the first question. So we have three particles moving along the vectors this respectively. They strike on a point and start to move in different directions. Now particle P is moving normal to the plane which contains A and B, and Q is moving normal to the plane which contains A and C. The angle between the direction of P and Q is how much? Yes, this is tough question, right? But yeah, we'll do this one. We'll do this one, but let's do a simple question first, right? But let me ask you that if you have already understood about the vectors. So if I want to calculate a vector which is perpendicular, or this is also called normal, to vectors A and B.